episode of the National Association of Scholars webinar series, Restoring the Sciences. I'm Scott Turner. I'm Director of Science Programs here at the National Association of Scholars, and I'm the regular host for this webinar series. And the National Association of Scholars obviously sponsors this webinar series. Today's webinar is around the topic Rethinking Climate Risk, and it's a special webinar for a couple of reasons. The first reason is our guest, Judith Curry, who is Emerita Professor of Earth and Atmospheric Science, the Earth and Atmospheric Sciences program at Georgia Tech University. I describe Judith Curry as a climate realist. She's emerged as one of several public faces representing climate realism, which is to say that before we are all stampeded into a climate panic, that we pause, take a breath, and think realistically about the issue. Since retiring from Georgia Tech, she has founded and is president of the Climate Forecast Applications Network, which provides intelligence to manage weather and climate-related risks. She's recently published a very fine book, Climate Uncertainty and Risk, Rethinking Our Response. This is from Anthem Press, and it's available on Amazon. And she also posts regularly to her blog, Climate Etc., at her website, judithcurry.com. And I'll be putting links to all these things momentarily into the chat box. The second reason today's episode is special is that we have a guest host. Kathryn Kelly is president of the firm Delta Toxicology, Inc., and she's also co-chair of the Nevada chapter of the National Association of Scholars, and she's active in science education. She's founder and president of iSchool, which seeks to formulate innovative methods of teaching science to students in grades 1 through 12. And I'll be putting a link to iSchool into the chat box as well. Before I turn things over to Kathryn and Judith, there are just a couple of housekeeping issues I want to bring up. We'll all be having a discussion among ourselves for about 45 minutes or so, after which we'll be opening the floor to questions from you, the audience, which is probably the most important aspect of these webinars. We encourage everyone to ask questions and to ask them at any time during the webinar. You don't need to wait until the floor has been open for questions. We'd like, if you can, to put your questions into the Q&A box, which is located at the bottom of your screen. We can also handle questions put into the chat box, but we like the Q&A box because it's a little bit more interactive, and so we prefer that. But the main thing is that you feel free to put questions in there at any time. Also, today's webinar will be available on YouTube shortly after we wrap up today. And of course, another place to ask questions is to put them into the comments section on the YouTube video. Okay, without further ado, let me hand over the program to Judith Curry and Kathryn Kelly. Welcome to the both of you to Restoring the Sciences.
Thank you, and hello to everybody from Nevada. And I'm delighted to have Judy Curry here, a fellow now Nevadan, moved across the country from Georgia. Judy, welcome. Without further ado, let's jump into your presentation.
Well, I don't have a presentation. I can tell you a little bit about my book and about what I'm all about. Well, my journey in this rather unusual direction started in 2010 when I became concerned about the behavior of climate scientists, particularly IPCC authors. It was becoming so political. They were trying to sabotage their opponents, evade Freedom of Information Act requests. And I became very concerned by all this. And I called them out on it publicly, saying that we need to do better. We need to make all of our data and methods publicly available, complete transparency. We need to be more honest about uncertainty, and we have to be respectful to other scientists who are critical of our research, and we have to engage them in constructive dialogue and debate as we try to move our understanding forward. Now, all that may sound like motherhood and apple pie, but there was a huge backlash against me by the climatariat, the important scientists and the IPCC or whatever. Who am I to criticize all these important people? And on it goes. So the more pushback I got from the climate science establishment, if you will, I became very popular with people from other different fields, from the policy sciences and the social sciences and engineers and oceanographers and communication specialists and philosopher of sciences who thought my arguments, were interesting and important. When I started my blog shortly after that, I mean, the idea of my blog was to, look at all these hidden assumptions and all the uncertainties that the climate establishment was trying to sweep under the rug. Let's get all these things out into the open, the value judgments, all of these things that nobody's talking about, but are, basic to the simplistic narrative that the UN has put forth. And so, I increasingly drew the ire of the climate establishment as I was doing this. And, academia became increasingly uncomfortable. I seeded my blog with a series on climate science and the uncertainty monster, which represented a major theme of my work following 2010, both academic and in the public communications world. And when, academia just became very uncomfortable, I was being marginalized, and it was impossible for me to find another academic position. I mean, if you Google Judith Curry at the time, you would see Judith Curry, serial climate misinformer, Judith Curry, climate denier. And that was my, the whole profile on page one of my a Google search for Judith Curry. I was, unhireable in academia at that point. So I said, okay. So I headed for the private sector. I had started a company a few years before, and then I just went full time in my company. And I tell you, I couldn't be happier than where I am right now. But so that's my backstory. But onto the book. Climate uncertainty and risk, a big part of what I do in my company is help my clients better understand weather and climate risk, and to help them develop strategies to manage those risks. Okay, and it's a very sort of different process that I go through with my clients, people who are making real decisions about their company, about their city, about whatever, than what you hear from the top down UN, we need to eliminate fossil fuels urgently, or, we're going to boil, or we're going to be extinct, or whatever the narrative du jour is. So I developed this interest and this knowledge about the risk sciences that is, to me, is so central to how we should be thinking about the climate issue and how we should consider responding to it. So my book, I'll just maybe hold it up quickly so you can see the cover. Climate Uncertainty and Risk, Rethinking Our Response, sort of is my sort of holistic, integrated take on this whole issue, ranging, from the sociology of science, the politicization of the whole thing, how we should think about scenarios of how the 21st century weather and climate may play out, and then also risk assessment and risk management strategies that make sense for a very complex, uncertain, ambiguous, wicked problem such as climate change. So that's the backstory and the quick summary on my book.
That's a great summary. Thank you. Do you do a book tour with something as in-depth as climate science?
I live in Zoom world. I do. Okay, last week was crazy. I was doing 2 to 3 interviews, podcasts, whatever a day. This week is a bit tamer. I think I had 6 interviews. So I'm doing a lot of, long form podcasts and radio shows and, a range of things, trying people are interested. I'm enjoying talking with all these different people, all of whom have read the book, and they all focus on different things. They resonated with different aspects of the book, and I just find it fascinating as to which person responded and their with a given background responded to which aspect of the book. And I found that really interesting. But I think, but the most interesting, even though I've been categorized as a denier, contrarian, whatever, I've gotten decent reviews from people on the more alarmed side. They might give me 4 stars instead of 5 stars, but they basically said, although the book is biased, there's a lot of good information here, and there's some interesting ideas and solutions. So I haven't really gotten hammered by the alarmed side of this debate. I tried to make the book ruthlessly apolitical, and try to present both sides fairly. And yeah, so I mean, I'm sort of surprised that I haven't got trashed by the alarmist side of this issue. So
do you sense that the pendulum is at all starting to swing back due to the efforts of you and other kind of brave scientists that are trying to speak the truth to these issues and research and write about it?
Well, a key aspect of the risk management approach is not to focus on the assumptions, but focus on the solutions. Here we have 2 sides here, each, insisting that their version of the facts, the scientific facts, is the right one, and both have, deep uncertainties surrounding their so-called facts. And, this whole thing has been scientized, which has been a mistake. I mean, instead, let's talk about good policies that make sense no matter how the climate plays out, that doesn't depend on getting people to agree on the scientific assumptions. I mean, research and development into new energy technologies that are cleaner, cheaper, more abundant, whatever. I mean, energy efficiency, better water management, resource management technology. These kind of things are things that everyone can agree on. We don't have to agree on, the scientific aspects of it. So that's part of the solution space that I recommend, is like and agree on a robust decision making. Agree on the solutions. Don't bother trying to agree on the assumptions, because it's not going to happen when you have a highly uncertain, politically contested issue.
Well, you're smart to focus on the solutions, because at the end of the day, we all want to live in a healthy, clean environment. And it's great that you have laid out a lot of the suggested steps to come to those solutions, and a process by which we can hopefully come to more agreement than not.
Yeah, I think there's ways forward. I mean, the real enemy of doing anything sensible is the urgency, the code red kind of things, where we have to urgently eliminate fossil fuels, which means jeopardizing the reliability of our electric systems. It's going to increase the cost. It's going to exacerbate land use issues. It's the big footprint required by wind and solar is very harmful to ecosystems, and so it's just not a good solution. And they say, well, that's the only option we have, because we have to do it urgently. Nuclear power plants take 10 years to build, things like that. Well, just drop the urgency, okay, and drop the top-down mandates and all these targets and deadlines, and let each community, each state, each country work on solutions and policies that they think will secure their common interests. So more of a bottom-up approach is going to lead us to better and more politically viable solutions than these top-down mandates from the UN, which, nobody can meet. And it just it's just the source of so much acrimony and polarization that we're never going to get anywhere on this topic.
Are you hearing from some government agencies about how to implement some of your ideas?
I do have some clients among government agencies, even some international ones, focused on specific topics like hurricane risk is a big one, and sea level rise is another big one. So, people listen to me. Governments, not the U.S., not the White House, not the UN, but I do have government clients that I'm working with.
And there's a question here. Do you also have clients in the fossil fuel industry?
Okay, even back when I was in more of an alarmist mode, I was providing hurricane forecasts to petroleum companies. Remember Hurricane Katrina, this wipe. Oh, it was a huge impact on the petroleum industry. Gas and oil prices spiked like crazy. And there was even Hurricane Gusto, I think it was 2008, maybe, that wiped out all the refining capacity on the Louisiana. And you couldn't get, in big parts of the US, you could not get any gasoline for your car for weeks. Okay, so this has a huge impact on petroleum companies. I provide weather forecasts to natural gas traders. And this is important for supporting the renewable energy industry, because wind and solar are so intermittent, it has to be backed up with gas. And this is a very delicate balance. You have to make sure that, you have the supply that you need, but that you're not paying too much. And so that's what natural gas trading does. A number of my clients are electric utilities companies who are trying to want better predictions of extreme weather events so they can predict and manage outages so they can restore power as quickly as possible. So yeah, I have, there's money from energy companies that lands in my company's bank accounts. However, I have never taken any funding from any company to speak publicly in a certain way about the climate change issue. What I'm providing them is information, proprietary information to these companies to help them manage their weather and climate risk. And when people say, oh, she's in the pay of big oil. Okay, back in the day when I was at Georgia Tech, I was making a whole lot more money from my Georgia Tech salary. It was an administrative salary than I've made, from my company. So if this was about lining my personal pockets, I would have stayed at Georgia Tech and played the game.
Good for you. I've always had trouble with the perception that just because you provide a service to the private sector or petroleum or citizen groups or whatever, that somehow they're buying your opinion or influencing the science somehow. I am glad for myself that petroleum industry is stepping up and wanting to learn from you what their part is in this whole picture and how they can be a creative part of the process.
Well, another thing is one of the things that my company does is we educate companies about climate change and the various risks. People oil companies who might be getting sued over sea level rise in a certain location, or a power plant, a company who's trying to install a power plant and somebody's suing them over that. And I help educate them about, what are the real issues? What are the real risks? Which of these assertions made in the complaint are justified and which aren't. So I play a big role in educating clients about their climate change risk and how to deal with litigation.
Good for you. I don't know if you can reduce the main takeaways in such a multifaceted topic, but what would you say are the 2, 3, 4 main takeaways that you would like people to understand from your book with 1,500 references? You can go deep into the weeds, but I'm asking for an overflight of what you think the key messages are.
Okay, well, the first thing is we've badly mischaracterized climate risk. I mean, the slow creep of warming really influences sea level rise, melting of glaciers, things like that. The extreme weather
It seems to have frozen here. Maybe this is the time to introduce a point that's maybe as a counter argument to something that's playing out in the chat session. Judith, are you back with us? Of course, there's this trope that anyone who expresses skepticism is somehow in the pocket of an unfavored industry. I think we've lost Judy, and of course the counter question is, well, just how much money is flowing through the people who are pushing the notion of a climate crisis? And I have some personal experience with this. I've done quite a lot of my work in research in Southern Africa and Namibia particularly, and this is a place that has enormous reserves of not only fossil fuels, but also uranium for nuclear power industry. And those have been completely gutted by the amount of money that's funneled into their economy by the IPCC, the Green Climate Fund, and so forth. And it's had the essential effect of suppressing an industry in that country, which is capable of providing the energy that they need for economic development, but it's being throttled by this extra money coming in. So certainly the other side of this question of who's funding you has to be who's funding the other side as well. And Judy, while you were away, I just was making this point that there's two sides to this story, and that we should be aware that to the extent that money and power actually promotes the climate catastrophist agenda. So,
yeah, I'm sorry, I lost my Zoom connection.
No worries, it happens.
I moved to another room in case it was an internet issue.
Yeah,
but the issue of funding is such a canard. The government funding really torques the research in many ways. In climate science, all the announcements of opportunity implicitly or explicitly, assume dangerous human-caused warming and ask for proposals, related to that. It's very hard to get anything else funded. So there's agendas all over the place, and there's fossil fuel money all over the place in many universities, but the amount of money spent by billionaire environmental activists is huge. I mean, it dwarfs anything from the oil companies in terms of what they're spending on this issue. So, I mean, money influences everywhere, but so it's everywhere. It's just background noise, in my opinion. So you just listen to the arguments. Don't try to tar somebody, with their funding sources. Just listen to their arguments. And nobody seems willing to do that. It's so tribal, and they throw you into one tribe or another, and then they dismiss you or, follow you, depending on which tribe you align with. So it's just become completely divorced of reason, logic, and genuine argumentation.
And it's unfortunate. So key takeaway number one is we've mischaracterized the risk. What's another one?
Okay. The other one is that natural variability dominates our weather and climate extremes. And even if we were, successful at eliminating fossil fuels, say by 2040 or 2050 or whatever, even if you believe the climate models, we probably wouldn't notice any different in the weather until the 22nd century. So thinking that we're going to control the weather is, is just hubris beyond anything that makes sense. So that leads to the point is that we cannot control the climate. Okay, humans do impact the climate in unintended ways, and in principle, they can influence it in intended ways, geoengineering and things like that, but they can't control the weather and climate. And we just need to abandon that idea and get on with, more realistic solutions and more feasible solutions. Okay, what else? That the other point is, and I made this before, is that the best solutions are bottom up. They're not top down. These mandates from the UN, emissions targets and deadlines, and on it goes. They're meaningless, and they're not science driven. They're politically driven, to amplify the emergency as much as they politically think is feasible. They're not science driven targets. So we just need to drop that, and we need to support and enable individual countries, individual states, individual communities to try to figure out what makes sense for managing their resources, for providing energy, transportation, water, and food, and while at the same time protecting their environment, as much as they can within reason. I mean, we have to recognize we're 8 billion people on this planet, and we're going to have an impact on the planet. At the same time, we shouldn't trash the environment unnecessarily, and sort of old-fashioned environmentalism that worries about, water and air pollution and species. Can we go back to that, please? Rather than, that's all been completely dismissed in favor of the climate change agenda with adverse impacts on the environment and species in many ways, mining, and on it goes. So, those are some of the main points. But
thank you.
Okay.
No, add to that if you would like, or we'll ask you the next question. One
more point. In the middle part of the book, I talk about scenarios of the 21st century and how we should think about how this might play out. And I put it out, and I dismiss climate models as not being useful for this purpose. They're too narrowly focused, and they don't handle natural variability correctly, and on it goes. And so I put out, there are some different methods for generating scenarios of future climate, including plausible worst cases of specific events, warming and things like that. And so the problem with climate science is that we've been computing too much and thinking too little. We're just trusting what comes out of these climate models. And it's just, there's a growing realization, even from the establishment, that these climate models are running too hot. They're not useful for decadal scale simulations or regional assessments, anything like that. They're useful for, testing the sensitivity to different amounts of emissions. That's about, all they're useful for in the end. So we just need other ways of trying to think about what weather and climate hazards we might be facing in the 21st century.
Thank you. You've got a unique overview of what we know and what we don't know. What to you are the really interesting areas of research that we need to learn more about?
Oh my gosh, well, everything. Okay, the big categories of what we don't know. We don't know how much of the recent warming is caused by human-caused emissions. We don't know how the climate of the 21st century will play out. We don't know whether warming is dangerous. This is largely an issue of values that, to be resolved by the political process. It's not something that science can tell you. And we don't know whether a rapid transition to reduce CO2 emissions will overall be beneficial to humankind. I argue in my book that it probably won't, and that the transition risk that we're undergoing with this rapid transition to wind and solar is probably far greater than any near-term risks from weather hazards and climate change that we're going to see in the coming decades. So, and then when you get down to more detailed scientific things, we don't understand the fast feed. We don't have a good quantitative understanding of the fast feedbacks in the climate system. We don't have a quantitative understanding of the carbon budget and processes related to the carbon cycle. We don't have a good understanding of the vertical ocean heat and carbon transport in the ocean. We don't understand how to predict the natural modes, the multi-decadal to millennial scale modes of ocean variability. Clouds is a huge area of uncertainty. We don't know if the clouds are a positive or a negative feedback as a result to warming. I mean, we just don't know. I mean, there are all sorts of, we don't know how to model ice sheet dynamics or how to realistically predict what might trigger collapse of the West Antarctic ice sheet. I mean, there's a huge long list, but you hear the science is settled, you know. And
98% consensus, right?
Yeah. Oh, yeah. Then you have the consensus. Well, I have to say a few words about consensus since you brought it up. I mean, you see, what we have is a manufactured consensus about climate change, you know, a naturally occurring scientific consensus. You know, the Earth orbits the sun. I mean, you don't have to talk about consensus on that one. It's a well-known fact. Nobody disputes it. But when you have something complex, uncertain and politically important, policymakers will ask scientists to come to an agreement, you know, give me a consensus. And of course, the scientists are carefully picked to give the policymakers the answer they want. And then you have, you know, the IPCC is just a big consensus manufacturing exercise. So it's a manufactured consensus, and it really, it doesn't mean anything other than it just reflects the naive way that the policymakers think that they can handle uncertainty about this whole thing, you know, by wiping it out. And it's been so polarizing in the scientific community. It's misled policymakers, and it's driven us to this urgency of rapidly reducing fossil fuel emissions that is infeasible and will actually, if we do this very quickly, it will leave us much worse off economically and much more vulnerable to extreme weather events.
Well, thank you for that. Obviously, you've given that topic a great deal of thought. For all you participants, Scott is monitoring the questions so that he can cover them all in the Q&A. But there's a question in the chat room about what do you think about Alex Epstein's work? If I got that right.
Okay, he makes the point that we need energy. Okay, and we certainly do. And we're going to need more energy than we're currently using, especially if we electrify everything. But we need electricity to protect ourselves from weather and climate change, air conditioners, desalination plants, you know, air cleaners, vertical farming, all these things. But we also need it to advance, you know, humankind forward, quantum this and robotics that, and, you know, all these sensors and smart this are all based on computers. Advanced materials research is based on computers. So in order to, which require massive amounts of electricity. So we need a lot more, order of magnitude, more electricity in the short term. And this doesn't even account electrifying Africa. The most egregious thing about international climate policy is that we can't afford for Africa to develop its fossil fuels, because that would put us over some targets. I mean, you've got 1 billion people, farming without machinery, no grid electricity. I mean, it's reprehensible that what used to be, funds for development are now redirected towards renewable energy, and, to the great detriment of the development of Africa. So, I mean, it's just
for Maui.
Yeah, exactly. Okay, so back to Alex Epstein. I mean, he talks, in my opinion, he pushes in the near term, we need fossil fuels. But I think when you look forward to the 22nd century, I don't think we're going to still be burning fossil fuels for electricity. I mean, I think there'll be better fuels. So let's promote innovation, nuclear, advanced geothermal, and on it goes. I mean, there's all sorts of innovations that I would hope for in the 21st century. So I have no particular attachment to fossil fuels. I hope we come up with better solutions, but wind and solar are not it.
Thank you for that.
And
Scott,
just to jump in here about Africa, while the gods of Zoom were raining fire and brimstone on your computer, Judy, we introduced, we filled in with a little bit of a conversation about energy policy in Namibia, which is where I worked on my own research for many years, and they have basically gutted their fossil fuels industry, and this is a country that imports nearly 75% of its energy from outside, and they have abundant energy resources that they can develop themselves, but their fossil fuel industry is being crushed under the thumb of the IPCC and Green Climate Fund funding. They basically bought off the economy of that country. And the irony there is that if you look at the impact of Namibia on global carbon emissions, that country accounts for 0.03% of total carbon emissions. So you're basically holding that country in as economic hostages to this agenda, and to no impact whatsoever on the global carbon budget, which supposedly is the villain at the heart of all this. So, and certainly at the latest, was it COP27 or COP28?
COP27, yeah.
COP27, there was a movement afoot, complete with a slogan and a meme, "Don't gas Africa," and that was so egregious that even some of the African presidents were pushing back against this. I believe it was the president of Chad who pointed out that, well, hang on, what are you talking about? This is an abundant, cheap, and relatively clean source of energy for us. And there's an absolute, almost inevitable causation, I would say, between energy use per capita and gross domestic product per capita. It's a very clear relationship if you plot those things out. And so the whole climate agenda is really impacting badly on the global South, which of course is the poorest half of our globe.
Yeah, they call it green colonialism, energy apartheid, and I think those are very apt descriptors.
Yeah.
Scott, we have 12 questions to get through. You want to jump into the Q&A?
I see that. Yes. Okay. So let's go to the Q&A, and we'll work in the comments in the chat as well, because there's quite a number of comments in the chat box. So let's go first to Jay Reisman. He says that implementing net zero is now the basic blue state policy position, and by blue state, I'm assuming he means not only states within the United States, but also governments, nations following what Walter Mead is called the blue model. And his question is, based on IPCC modeling, how much climate change will this avert? Do we know?
It won't be noticeable against natural climate variability. I think 50 years, okay, there was some climate model simulations, 50 years after cessation of CO2 emissions, some models are still warming and others are still cooling. Yeah, others are cooling. So we don't really know how the carbon cycle is going to react to all that. In terms of extreme weather events, which is the main concern, if you look at the media, you wouldn't even notice a change until sometime in the 22nd century. So it's really about maybe preventing something really bad from happening in the 22nd or 23rd century, like collapse of an ice sheet or something like that.
So basically, we have no clue on how much climate change this will avert, and certainly not in the short term when we see in the news every night that the weather has become almost weaponized, with weather events suddenly becoming evidence of climate change, like hot temperatures in summer. So our friend Dick Linson, he has a question, which is an interesting one. Science is supposed to be kind of independent and skeptical, and he asked whether you think that politics have impeded actual research that would reduce uncertainty, the kinds of things that are bedeviling the rational consideration of climate change.
Chapter 4 of my book. I mean, absolutely. This is, there's been no, the whole issue of natural climate variability has been completely marginalized. NASA keeps funding some solar climate research, which is good, but more ocean related and geothermal kind of natural variability has really been completely marginalized. There's no, the whole IPCC thing is about consensus and increasing confidence, and what's really needed is to explore uncertainty. And the Department of Energy has been trying to quantify uncertainty in climate models, which I think is a hopeless task, but at least they're acknowledging that there is uncertainty. But yeah, no, we've completely missed the opportunity. I mean, you have to go back to the first assessment report, I guess, in 1990, and they laid out a good agenda for climate research, and they talked about, what we don't know, and that would have been a great agenda for climate research. However, since then, everything is focused on the assumption of dangerous human-caused climate change, and too much of the funding, it goes to what I call climate model taxonomy, where you look at the output of climate models to try to find something alarming, like we won't be able to grow grapes in China and that'll tank the wine industry, on and on it goes. There's millions of examples like that. And that's what gets funded. It gets headlines, it gets the scientists who publish those papers get rewarded, at their universities and by professional societies. And you have this whole, the social contract between scientists and the policymakers just to, reinforce this whole alarming narrative. And, the people who are doing the other kind of research are people in the private sector or retired people, who don't rely on funding. And there's a few sort of think tank type organizations who fund a little bit of this research, but it's several orders of magnitude smaller than the funding that you get from the billionaire environmental activists. So it's a very small community of people doing this kind of work. And in the universities, it's bad because, back in the day, 1970s, 1980s, whatever, you studied geology, atmospheric science, oceanography, and you had a deep understanding. Now you get your degree in climate studies, and the only scientific part of this is they teach you how to recite IPCC talking points. You don't develop any understanding of the science that's described in the IPCC. Worse yet, there are very few scientists left that can critically evaluate the science in the IPCC assessment reports. Richard Lindzen is certainly one of them. But the people who can critically evaluate all this are small in number, and the number is decreasing as this generation who really understood the dynamics of this are getting older and older. So it's a very big problem.
So just how did uncertainty and variability become dirty words in the whole climate debate?
Naomi Oreskes, The Merchants of Doubt, this book, okay? It talked about how the tobacco, and Dick Linson knows this story very well, is about how the tobacco companies bought off scientists to claim that it was uncertain as to what the impacts of smoking, particularly secondhand smoke. And so doubt and uncertainty became dirty words that vested industrial interests were trying to sow doubt and uncertainty so as to prevent action. And then they claimed that the climate scientists, the skeptical climate scientists were playing from this same playbook. So the word uncertainty and doubt automatically equated you with the evil tobacco companies in terms of your behavior as a scientist. And people just bought into that uncritically. Everybody likes a simple story. and there is no simple story about the complex, highly uncertain climate change problem.
Is there something more than just a love of simplicity there, though? Because
power,
well, exactly, power and money, and of course this goes right to the heart of an issue that we're concerned with here at the National Association of Scholars, which is that the universities have become totally captured by a certain political narrative, which is held in place by spending money, government money, and also the pursuit of power. And, that seems to me to be at the heart of this alarmist climate agenda. There's no science involved there. It's all pursuit of money and power, it seems to me.
That's pretty much the case. I mean, like I said, the scientists, the true scientists who have enough knowledge and understanding to critically evaluate climate science and the IPCC's finding are very few and far between, and they all get tossed into the denier camp because they use the words uncertainty and natural climate variability.
Yeah. Okay. So let's move on to another question here. Walter Hogel asks this question: implementing a completely new and independent surface temperature data set with no need for adjustments, et cetera, would that help restore the science to climate change or climate science? He goes on to say that urbanization / poor surface station placement, these are corrupting the data, and we're not really getting an accurate representation of what the climate is doing. Are we improving our assessment of uncertainty and risk, or is it sort of?
Okay, the measurements, the surface temperature measurements are in a sad state. And I don't, there's inexpensive instruments that are out there. We know where to cite these sensors, but, it's not going to happen. So we need to get over that. I think the reanalyses, the global reanalysis done by the European Center for Medium Range Forecasting, the Japanese Meteorological Organization and NOAA, I think that these dynamically integrate a whole bunch of observations, and then they do produce, among other things, a global surface temperature data set. And I find this to be more objective than analyses that are solely observationally based. And I think they're less susceptible to urban heat island effects, because they don't explicitly occur in the model. The fact that there's an urban heat island. I even noticed in my weather forecasting that we have to do there's a lot of bias correcting that needs to be done when we're in an urban heat island situation. So I think these reanalysis data sets are getting better and better, and I think they're far more objective than surface instrument-based data sets.
But are they reducing the uncertainty or just making the
Well, I mean,
uncertainty
the
more clear?
uncertainty, yeah, the uncertainty relates to our understanding of what's causing these variations.
Yes.
And the focus on, to me, on the global temperature is misleading because, I mean, it's the regional climate change and variability which matters to people. You've got some places cooling, some places warming, some places warming a lot, you know. There's so much regional variability that this is where we should focus our attention on, particularly with regards to the paleoclimate data record. Trying to get some sort of global paleoclimate average temperature is a pointless exercise, but can we please apply this paleoclimate data to better understanding regional climate variability and change? So, you know, I think this idea of global temperature is sort of, the focus on that is misleading. If you're, I mean, just from a socioeconomic point of view, and even from a scientific point of view, I think the regional change and variability is far more important and far more interesting.
Dave Peterson asks kind of a follow-up question to that, but this involves comparison of observational research, I think, compared to the computer modeling. So this improved set of data that you just mentioned is being developed. Has that made the computer models better or made them look more out of touch with reality?
Well, the latest version, the CMIC 6 version of the global climate models, which were used in the IPCC 6 assessment report, were worse than the previous generation. They were, a majority of them were running way too hot. And this really had to do mostly with the changes to cloud microphysical parameterizations and how cloud particles interacted with aerosols. And it was this change that made them overly sensitive to warming, made the feedbacks too high. So a couple of lessons here. The more complicated you make these models, putting more and more stuff into it, you know, with chemistry and cloud microphysics and things like that, you're not necessarily getting a better solution in terms of the global climate model. And the second issue is that the climate models, the climate modeling has become a topic of interest for philosophers of science, and they have some very interesting insights. Among them is that these climate models are so uncertain that any serious attempt at model verification with observations is probably pointless. You know, you're talking many, many millions of degrees of freedom. I mean, how do you evaluate them? On what spatial scale, what time scale, which variables, which levels in the atmosphere? People have attempted to do this, and you come up with, well, a couple of climate models are really bad, obviously. Some are better, but still not very good. So what does that leave you with? Not very much. So I think we have to work around. There's a lot more emphasis, even in the most recent IPCC report, on simpler models, you know, climate emulators and things like that, you know, for very specific applications. And I think this makes more sense than trying to use these very intractable coupled Earth system models that they're useful for exploring processes and tweaking them and playing games with them, and maybe we can learn something from it. But for use in prediction or in attribution studies, I don't think they're useful at all. We just need to move on from the climate models. Think harder and compute less, in my opinion.
Yes, I'm going to remember that.
I have a format question for you. What do we do when we have more questions than we have time to answer? Do we ask Judy to stay over? Do we?
I'm game. I'm game.
Okay.
Nothing else,
Thank you.
nothing else is on my schedule. This is fun. Yeah,
our nominal runtime is an hour, but we often go for as long as 90 minutes. So we try to, if our guest is willing, and Judy, you have said that you are, we'll we'll run out the clock to 90 minutes to try and get in the questions. But if we
Great,
don't get
great
questions,
Thank you.
they are great questions, and I hope to get to all of them. But again, if we don't get to all of the questions, I'll mention this at the end as well. Then what we typically do is ask everyone to submit their questions to me at my email address at NAS. That's turner@nas.org, and I'll do my best to get them into the hands of either Judy or Kathryn. And of course, as I mentioned, the YouTube video, there's a comment section there, and I try to go through and monitor that to answer any questions that come up there. So that's the format there. So.
Thank you.
So not to take away any more of our time for Q&A. So there are several questions. Jack Budney, for example, has posted a couple of these, but there are other aspects of this question. He asked, to what extent have you experienced or perceived the climate change issue as a vehicle to control society rather than to solve a problem that society needs to solve? And by the problem, I'm presuming he means what do we do if the climate goes askew?
Well,
Or
yeah.
are we using this to control our society as an instrument of political power rather than science?
Okay, well, you have to go back to the 1980s, the UN Environmental Program, very anti-capitalist, trying to promote non-governmental UN control over a lot of things. And they picked up on climate change as an ideal vehicle for this. And, and they pushed this hard. And, in 1992, we had the UN Framework Convention on Climate Change Treaty to prevent dangerous anthropogenic climate change. And this was before there was any evidence of any anomalous warming at all. And the US even signed this treaty. So you had the policy cart way out in front of the scientific horse from the very beginning of this. Okay. And, in the US, the two political parties have evolved, where, at least in the current Democratic administration, they seem to be in favor of control, thinking about declaring a climate emergency, more COVID lockdowns, et cetera, where the other political party is, none of that. Thank you. Primarily concerned about freedoms. And so, yeah, there's all sorts of politics in this from the very beginning. And, we've had this whole, the evolution of the science has been so constrained by the UN agenda in terms of national funding priorities, and on it goes, and what universities perceive as being the right thing to do, and the topics that will attract funding from donors. Like I said, there's just this whole positive feedback between the scientists and the policymakers that have brought us to this sorry state.
Okay, so we'll probably come back to that with some further comments. But if we go to the chat box, there are a couple of interesting questions. Actually, there are many interesting questions in there, but let me just focus on a couple of them. Sagar, this is the person's tag, asks that the renewables industry knows that for many years they can't make their own products without burning fossil fuels. And of course, I would just add to that the enormous environmental impact of mining the metals and minerals and materials that will have to go into, basically, bringing solar power or wind up to a major contributor to our energy budget. And so somehow the politics have actually led us to ignore that impact. I rarely see any comments about just how what the environmental footprint is for say fracking and horizontal drilling versus mining lithium. And then the other one, Walter Jakubowski, I hope I pronounced your name correctly, Walter. How does one respond to the alarmist view that we have created an anthropogenic runaway greenhouse? So these two questions sort of address the trade-offs that we are being asked to make between fossil fuels and the impacts of going full solar and full wind.
Okay, well, we can dismiss the runaway feedback. Just read the IPCC. Okay, put on your thinking cap. Take some effort to read the scientific literature and the IPCC reports. Runaway greenhouse, there's no such thing. Even the UN is now talking about expecting 2.5 degrees centigrade of warming by the end of the 21st century. And we've already warmed 1.2. So we're talking about another 1.3 degrees. I mean, so the climate crisis isn't what it used to be, but that doesn't stop the alarming rhetoric. Okay, back to the other question, renewables. Okay, I am not a fan of wind. I think there's a place for rooftop solar. But we're told that wind and solar energy is free. There's no greenhouse gas emissions. Okay. Well, of course, there's greenhouse gas emissions. You look at the cement, especially in these wind turbines, and the fiberglass and the steel and whatever, this is all made with fossil fuels. Okay. And the transportation of these things, if you're, on the big interstates, you see these insane, trucks transporting this stuff. These things are huge. They're massive. Okay, huge amount of fossil fuels needed to implement all this. I mean, the mining, I mean, there's a reason all the rare earth mines are in China and Africa is because the US and Europe don't want to trash their environment to do this mining, which is tremendously hard on the land and the landscape and pollutes and on it goes. So this is not a good thing. But the bigger issues is wind and solar will not work. It's not just the intermittency, it's the asynchronicity. You need to maintain frequency control. And once you lose that, your whole system crashes. So you have to back it up with natural gas, or you have to add very expensive synchronous condensers to your grid. And so what you have to do to the grid to make this workable is extremely expensive. And, battery storage is, just not up to the task at any kind of scale that you think it can happen. There's so many problems with this is chapter 14 in my book. There's a lot of problems with wind and solar. So, but the main thing, the urgency, even the UN, the COP27, they were working from a 2.5 degrees centigrade warming by the end of the 21st century. They finally got rid of all these extreme emission scenarios that gave you 4 or 5 degrees centigrade or 10 degrees Fahrenheit warming. They finally gotten rid of those crazy, implausible scenarios. So, I mean, what we're left with is a slow creep of warming that we can easily adapt to, or that could very likely be counteracted by some big volcanic eruptions, a solar minimum, on it goes. There's all sorts of natural variability that could act to counteract it. So we're just being stupid.
Speaking of volcanoes, Sharon in the Q&A asked a question about how the Tonga volcanic eruption of water vapor into the stratosphere may be affecting our current warming trend in global temperatures.
Okay, the Tonga eruption is a little bit subtle. Usually volcanoes erupt and put a bunch of sulfate particles into the stratosphere. Well, Tonga only put a small amount of sulfate particles into the atmosphere, put a bunch of water vapor into the atmosphere. So in the summer hemisphere, the long wave and the short wave effects of Tonga hard to cancel out. In the winter hemisphere, you have the long wave effect, which is a warming effect from Hunga Tonga. But I think the real impact of Hunga Tonga is on the dynamics right now we're seeing in the Southern Hemisphere, the winter, all sorts of weird things going on. An early onset for the ozone hole. We're seeing very strong winds in the region, which are pushing the sea ice against the continent, giving rise to a reduced extent of sea ice. So I think there's a lot of changes to the dynamics in the winter hemisphere associated with Hunga Tonga. That may be the main effect. But we could see the impact go on for, a decade, it slowly tapering down. It'll be interesting to see what it looks like in the Northern Hemisphere winter if we see some weird things also. So, but you have natural climate variability all the time happening. And, speaking of volcanoes, in the first half of the 19th century, there were 3 mega volcanic eruptions. The biggest one was Tambora, the year without, a winter, and that was estimated to have caused a drop of a 0.5 degree centigrade, over several decades. I mean, something like that happening in the 21st century would completely change the trajectory of climate over the 21st century. All this is being ignored. It's all being ignored.
Yeah, and of course, speaking of those huge impacts of things like volcanic eruptions, I mean, unthinkable amounts of energy go into that. We still see reports, I don't know if this is alarmist or not, of people thinking that they can engineer the climate by injecting particles into the stratosphere or having giant reflective satellites up there. And when I actually taught about this when I was an active faculty member, I used to tell students that people with environmental engineering solutions to this scare the bejesus out of me because they have no idea what they're talking about. And that was just my limited understanding. But Judith, what do you say about proposals for environmental engineering to manage climate?
Inadvertent climate impacts like emissions of CO2 and putting aerosols into the atmosphere. I mean, that happens on a slow incremental basis. A big, huge shock, like putting aerosol into the stratosphere, would have many unintended consequences that could be extremely undesirable. Why we would do this to prevent a small amount of warming, is absolutely beyond me. Absolutely beyond me. And once it gets into the stratosphere, it's not that easy to get rid of. And if you stop doing it, and then the warming would come right back. So it's just a terribly bad idea. A terribly bad idea. Sure, people talk about it and write papers and do modeling simulation, but okay, there are some, ideas for locally engineering, like in the summertime over the Greenland ice pack, putting some reflectors or something like that for a month during the peak melt season to try to slow that down to help maintain the Greenland ice balance. Something like that would be, I would expect, completely harmless, to the global and regional climate. But trying to do something like this stratospheric solar engineering would be an absolute catastrophe.
But do these ideas have any traction in the hands of the policymakers?
Oh, people talk about them, and people talk about them. There could be rogue people, doing something. So, it's just so utterly stupid. It's really utterly stupid.
Mm-hmm. Yeah, I think stupid is the way to go, but then we have to persuade the general public that it is stupid, and they seem to be very open to this media onslaught that somehow we're all in danger and we have to do something about it. And we see this on the nightly news every night almost. And so what's their motivation in pushing this climate agenda, alarmist climate agenda? What do they get from it?
It's, media attention, control, who knows what goes on, but they don't really understand climate dynamics if they're proposing stuff like this. I just send them back to look at the the first half of the 19th century and the impacts of those 3 volcanic eruptions and say, is this the world you want? No, it isn't.
So are we making any progress in informing the public better?
Geez, no, it's a pseudo-religious issue. I mean, it's all become cult-like. It's just insane. I mean, there's some oasis of, a number of oases of sanity out there. But, it's hard. It's hard. The information's out there, but it's being drowned in all the extinction, code red, and all that kind of rhetoric.
Yeah. I suppose because they are the ones that make the headlines.
Yes.
Yeah, with compelling video footage. There are several questions that I think we've already kind of addressed, but let me just lay them out for you. We've had a number of, Dave Peterson, for example, asks, is there any insight on issues of research done by computer modeling compared to observed measurement? And I think you've addressed that already, Judy, but do you have anything to add to that?
Well, I just think we need more climate dynamics using both models and observations to improve our understanding of how the system works. So just a model simulation and a bunch of data doesn't really increase understanding by itself.
Yeah. Gregory Campbell goes on to ask, are the models used by the spokesman for the climate crisis the same models that were incorrect for 30 years regarding global warming? And I think the answer to that is that the models have changed, but perhaps they haven't changed enough and in the right direction to give us a more realistic handle on climate change.
Well, the models aren't really helping that much, but, the alarmist rhetoric at this point is tied to extreme weather events. Oh my gosh, a heat wave. Oh my gosh, a flood. Oh my gosh, a hurricane. So, they blame every extreme weather event on human-caused global warming. And even the IPCC acknowledges that there's very little evidence that there's any influence of the CO2 emissions on worsening weather events. So it's just this very simple association, which of course gets amped in the media, and climate scientists, not climate dynamicists, climate scientists who are, looking for the cheap paper and the cheap publicity who hype this.
Again, we come back to the question, how is it that we as scientists can effectively fight back against this kind of thing? Because in my opinion, the whole science has been hijacked. Whole aspect of climate science has been hijacked by political interests, shoving scientists to the background. So how do we do it?
It's hard to do in the university. Okay, if you're in a government lab, you just keep your mouth shut. Okay. Mm-hmm. If you're at a university, you're taking a very big risk, even if you're tenured.
Yes, as you well know.
Okay, and this is why, in the private sector and in think tank type organizations, that this is really the place where these scientists are congregating and communicating with the public. I mean, many universities are hostile, not all of them, to, serious critical thinking and questioning about all this.
Okay, so Larry asks an interesting question in the Q&A. He says, Judith, one thing that has puzzled me is the notion of the Earth's correct temperature, in quotes, or normal temperature. Can you address that briefly?
Oh, yeah. Section 1.3 of my book. So what's
that's how good this book is. Yeah.
Okay, so what's the Goldilocks climate? Too hot, too warm, just right. Well, the IPCC has implicitly assumed that the pre-industrial climate was just right before fossil fuel emissions. Well, this was towards the end of the Little Ice Age, which was horrendously horrible weather. It was cold. There were famines. They were drowning witches because they needed somebody to blame the cold weather on. You had all those, a lot of volcanoes, solar minima. I mean, it was just very, very bad situation. And why we think that pre-industrial at those temperatures was just right, I don't know. There's a couple of papers where they've surveyed people, one in the US and one in China. Do you think that the weather now and the climate is better now or back in the 1980s? The general consensus is that the weather is better now than in the 1980s. In the US, people don't move north, they're moving south. The states with the big population increases are Florida, Texas, Arizona, not Montana. So, in terms of our preferences, people don't like cold winters. So why people think this is a bad climate, I don't know. Sea level rise is increasing at a slow creep since, like about 1860, at about 7 inches a century. It goes up and down with circulation patterns and El Niños and La Niñas and whatever. But, these crazy projections of 5 feet, 6 feet, sea level rise by 2100, it just isn't happening. So the whole issue of whether warming is dangerous is the weakest part of their whole argument.
Yes, and of course, never mind the issues of just what is global temperature, which you addressed in an earlier part of our discussion today. Just moving on here, Richard Voss asked an interesting question. He asked, what are your views on the issue of attribution? That is, to what extent and to what degree of certainty are anthropogenic CO2 emissions responsible, in contrast to natural causes, for any climate change that's actually occurring? And of course, climate is always changing. We know this. You mentioned that in the natural variability. So do we have a handle on how much anthropogenic CO2?
Well, we don't, because we haven't been giving attention to the natural components of climate variability. I mean, the climate models say 100%. The IPCC, the 5th assessment report, said more than half, but they really mean 100%. But okay, here's the uncertainties. I mean, we were in a grand solar maximum, in the last half of the 20th century, but the IPCC said it was a trivial effect. We do not properly understand the solar indirect effects, in addition to the actual insulation. So that's a big unknown. Some studies and some interpretations of solar indirect effects say that they're large enough to explain the warming in the second half of the 20th century, so who knows? The internal modes of climate variability, the multi-decadal variability in the Atlantic and ocean. Some estimates are that that's been 0.4 degrees centigrade in the second half of the 20th century. I mean, these are big effects. I mean, so in principle, you can plausibly explain most of the warming by natural climate variability. We don't know because we're not looking at this. We've put this very narrow frame around the issue, dangerous anthropogenic climate change, and everything outside of that frame just gets completely marginalized. So the sad state of affairs is that we really don't know, because we haven't been paying attention to trying to understand natural climate variability.
Okay. Sagar asked an interesting question, kind of related to what we were talking about how you reverse this. And he asks, with Niger and the rest of Africa starting to talk up that they want a fair price for their resources, and the Italian prime minister saying green energy is colonialist, she's making that point. Do you think that these voices may open up the debate about the ethics of renewables on many levels? Do you think that's the way to bring science back to this debate?
Well, I don't think it's going to help the science, but even if you electrify all of Africa to any reasonable level, I mean, this would not exceed 1% of global emissions. And to not do that for 1 billion people, I mean, it's just evil. Okay. the moral arguments are all over the place. Are you for the planet or against it? So trying to make moral arguments here doesn't always help. But you have to ask, what do we owe? People say, well, we owe and this is the lawsuits, our children's trust, the Montana lawsuit and Juliana lawsuit. We owe our children a stable climate, a safe environment. Well, the climate has never been stable. It's always out of equilibrium. It's always varying on many time scales. So, there's no way we can guarantee a stable climate. So we just need to get over that and figure out how we can adapt to climate variability and change, how to make societies more prosperous so they can afford to protect themselves from whatever bad climate and weather that nature might throw at us, and trying to inhibit economic development is really going to make, and to screw with our electricity supply is going to make all of us more vulnerable to extreme weather and climate events.
Yeah, and of course, one of the big issues in Africa, of course, is not only economic development, but the development of human rights, such as the right to freedom, free speech, and those kinds of things. And one question in the Q&A, I hope I pronounce this tag correctly, Tretioshu, he makes a point that others have made, which is that the climate change agenda, especially the alarmist one, is tied into pursuit of money and power, mostly by northern interests. And so he asked that, would you please comment on strategies to fight anti-freedom, anti-education, anti-science, anti-ethics, anti-Judeo-Christian ethos, and more. And we've spoken about education and facts and all these kinds of things, but this question seems to go more deeply into some fundamental questions of human rights.
Well, I wish I had answers, but I regard real education is key. I mean, critical thinking, not indoctrination, logic, debate, discussion. We need to, and freedom of speech is so central to all of that. So, I mean, this, to me, the freedom of speech and real education, is a foundation upon which everything else, can grow.
Yeah, and of course, one of the things is that you suppress those things to the extent that you make people dependent on higher level political power, which of course in this case includes what kinds of resources do you develop. And just to make a personal comment, that seems to be one of the things that's keeping political development in Africa down, is that we are creating a cotton of billions of dependent people who can't realize their own desires and agendas, and they're being held in place by a political structure that's actually empowered by the amount of money that's flowing into them from the Green Climate Fund and those sorts of politically motivated funding sources. So that's my thought on that. So let's see, let's go on. Okay, so, and of course, John Budney makes this point. I see, I just come across this, that this basically creates a situation of social slavery. And so we'll put that comment out there. Perhaps that will elicit some other comments here in the Q&A. Emily Hebner asked, how do satellite, space debris, and air travel impact temperatures and weather?
Well, so, I mean, air travel, contrails, jet contrails, those white streaks across the sky do have an effect on climate. There's some new ideas out there to use weather forecasts to better, estimate which altitude the plane should be flying to avoid making contrails. Of course, this might use more fuel if you're flying at a lower level, so there's trade-offs, but no, jet contrails are a factor in terms of influencing climate.
How about space debris?
Space should be, no, it's too small to
Mhm.
influence
Yeah.
our climate.
Dangerous to spacecraft, but I'm not so sure
Yeah.
it affects this unless it gets very, very thick indeed. We're reaching the end of our time here, so let's just start to wrap up here. So Sagar asks, we be doing more Zooms for more open debates so that people can learn to discern and rather than obey and follow corporate climate dogma? Interesting phrase. We need to hear your voices more on this. Thanks very much to you. But I would just mention to everyone that have a look at our Restoring the Sciences webinar, as well as webinar series, as well as many of the writings on the National Organization of Scholars website. That's nas.org. And, you'll find a lot of resources there. And we do have more planned coming up. So yes, thank you for that comment, Sagar. Let's see here. Moving on, Tretioshu talks about the Block the Sun to Prevent Global Warming by Biden regime and Gates. Okay, again, this is an aspect of social engineering, which I think we've already spoke about. Sagar asks, if you think roof solar is fine, then which African country will be still supplying us the key minerals when they plan to stop supplying to France? That's kind of an interesting geopolitical thing, quite real, but I don't know if you have any comments on
No?
that, Judy. Yeah,
No.
okay. All right. So yeah, and getting back to the universities, I just mentioned a personal experience. I was active in a college of environmental science in upstate New York here, and I vividly remember us having a teach-in on climate change. This was about 10 years ago, and the two positions were, do we panic now or do we panic later? And very little in the way of an objective assessment of the likelihood and perhaps dangers of changing climate. And with that, I think we will close out for today. I'd like to thank both you and you, Judy, and you, Kathryn, for appearing on today's Restoring the Sciences. It was thoroughly enjoying. We had a number of really wonderful questions. And again, I will just reiterate that if we didn't get to your question and you'd like it to be addressed as well, please do send me the questions at my email address at National Association of Scholars. And to repeat, that's turner@nas.org. And of course, if you enjoyed today's webinar, thanks for coming. We're really glad you're here. If you're already a member of the NAS, we thank you again for your support. And if you're not a member, consider joining us, because we're kind of a fun group, I can say that. And finally, I'd like to put in a plug for the next episode of Restoring the Sciences. This will be in 1 week, Friday, September 1st. And our guest that day is going to be Brian Frezza, who is CEO and founder of Emerald Cloud Labs. And he'll be discussing with us the practical aspects of doing science outside the university, and tangentially whether scientists can be better scientists outside the university rather than in. And there's a link to that at the beginning of the chat box as well. And we do hope that you consider joining us there. And again, I would just say, by all means, share this when it comes out. And it just remains for me to thank Judith and Kathryn for this fantastic conversation. And I will leave the final word to the both of you. Judy, why don't you go first?
Okay. Well, thank you, everyone. This was a very interesting conversation, and I appreciate you joining in. And, please continue the dialogue. You can join the discussion at my blog, Climate Etc., judithcurry.com. And I also look forward to your comments about my book, Climate Uncertainty and Risk. Leave a review at Amazon. I'm doing a number of these kind of podcasts in different venues with different people. And it's always interesting to see what kind of different questions and points, that get brought up. But I'm hoping, that this will spark a rational dialogue and at least some little corner of the scientific community.
Are you posting some of these interviews on your website?
Oh God, I've been slow. Some of them are. I should probably bring that up today, but you can just Google Judith Curry podcast or whatever, and a lot of them will pop up.
Great.
Yeah.
Well, Judy, we so appreciate the breadth of your research, the depth of your research, the critical thinking that you bring to it, and above all, your courage to share all this under sometimes very trying circumstances. You're really an inspiration to a lot of scientists out there of all generations. So thank you for sharing your time with us today.
Okay, well, thank you.
And I'll add my thanks to that and to the audience out there. When this YouTube video is up, by all means, share with all your friends and even your enemies. Okay. With that, I will bid the both of you goodbye. Thank you again for appearing on Restoring the Sciences. It was a wonderful discussion.
Thank you.